Hello and welcome to our presentation BIOMIN featuring RUSITEC today. My name is Melanie. I'm working within the recruiting department of the ERBER Group, and I'm very happy to welcome participants of 4 universities of 2 countries to our presentation today. Thank you very much for the great cooperation to the University of Göttingen, to the University of Hohenheim, to the University of Natural Resources and Life Sciences Vienna, and also to the Austrian Biotech University of Applied Sciences in Tulln. Please feel free to write your questions and comments in our chat section while we are presenting. We are happy to answer your questions afterwards. And the session will be recorded and sent to the representatives of the universities to share it with the participants afterwards. So I would say, let's start. First of all, I would like to give you a short overview about the group structure of the ERBER Group. The ERBER Group was founded back then in 1983 by Erich Erber, his wife, and a friend of them. Nowadays, we have 1,400 to 1,500 employees and 59 nationalities working all around the world for us. And with 19 production sites, we are serving customers in more than 120 countries with our products. Our biggest division is BIOMIN, and we are developing and producing feed additives and premixes for swine, poultry, ruminants, and aquaculture with BIOMIN. And of course, we have other divisions as well. And I want to switch here to the next slide because just giving you an impression of our products. So we serve with our products the whole value chain and supply chain. From biotechnologically plant protection products produced and developed by Biofirm through different diagnostic test kits and services provided by Roma Labs to animal health and feed additive products produced and developed by BIOMIN and Sanfar. So with BIOMIN, we are especially known for our mycotoxin risk management and gut performance products for farm animals, and we are over 3 and 5 years old now. We are very proud of our in-house R&D, which has the regional headquarters in Austria, with different departments like discovering and scouting, enzymology, analytical chemistry, but also gatomics, bioprocess development, cell biology, bioingredient formulation, and also product management and development teams. So in total, these are around about 200 scientists working for us only in Austria. Of course, we have some regional laboratories in other countries as well. So, and now I would like to hand over to my colleague, Christina Gruber. She's working for the development department as development scientist and coordinator, and she will now tell you more about RUSITEC and BIOMIN.
Christina, bitte deine Slides sharen jetzt.
Ja. Thank you, Melanie, for the introduction. We at BIOMIN strive to support animal health and performance in agriculture and also livestock production. Today, I have the great opportunity to give you an insight in our research that we are doing at BIOMIN. One of the foci are, for example, gastrointestinal diseases such as ruminal acidosis. So ruminal acidosis is a bovine metabolic disease that affects feedlot and also dairy cattle. Rumen acidosis is generally associated with an increase or in the ingestion of large amounts of highly fermentable carbohydrate-rich diets. So this carbohydrate-rich feeds basically result in the excessive production and also accumulation of short-chain fatty acids, also especially lactic acids in the rumen, which cause a drop in the ruminal pH and the potential of damaging the metabolic system. There are several forms of ruminal acidosis: the acute ruminal acidosis and the subacute ruminal acidosis. And especially in dairy cattle, the subacute form is relevant. And this is mainly caused by the change in the dairy industry that we have observed in the recent history. We have observed that the number of dairy farms has decreased, but at the same time we have also an increase in the individual milk yield per animal. This increase in the individual milk yield per animal was achieved by genetic selection, but also by a change in the diets, from a shift from more forage diets to grain including diets. And nowadays, these high performance dairy cattle require high starch diets, which in fact again cause the potential of subacute ruminal acidosis. So subacute ruminal acidosis has actually been identified as the most important nutritional disease in dairy cattle, and this is due to several facts, because there is a decrease in the dry matter intake of the animals, a decrease in the individual milk yield of the animals, and so for also a decrease in the productivity. At the same time, there is an increase in the culling rates and also in death and losses. So we have established that subacute ruminal acidosis can have a large impact on dairy farms and the productivity of them. I have already mentioned that subacute ruminal acidosis is caused by excessive amounts of highly fermentable carbohydrates in the diet. So this is mainly concentrate feeds that are fed to the animals. In contrast to the acute ruminal acidosis, the subacute ruminal acidosis is caused by the increased amount or total amount of short-chain fatty acids that are produced and accumulated in the rumen. And what we actually observe is that there is a disruption in the balance between the intake of fermentable carbohydrates, the buffering capacity of the rumen, and the rate of the rumen absorption of the acids. There are several definitions when subacute ruminal acidosis is defined, basically, and these definitions are always based on the time under a certain pH value. We have here two different examples. For example, the first one is a time of 5.24 hours below a pH value of 5.8, and the second definition is a 3-hour interval below 5.6 pH in the rumen. So now that we have established that the subacute ruminal acidosis can have a high impact and then also important influence of economic losses in dairy cattle, we can now establish how we can actually investigate this. And one of the options that we have is to use the rumen simulation technique, in short RUSITEC. This is a semi-continuous in vitro model which is well established for investigating ruminal fermentation in a standardized environment. This RUSITEC allows us not only to investigate ruminal fermentation processes, but with this RUSITEC we can also simulate subacute ruminal acidosis. So you can see here how the system looks like. We have 12 reactors that are filled with an inoculum, which is basically the rumen fluid of a cow. The inoculum is the same in every of the reactors, and the reactors represent our fermentation chambers. They are placed in a water bath in order to keep them in constant conditions and also under constant temperature, this 39 degrees. We have then also this continuous intake or inflow of synthetic saliva, which is provided via the synthetic saliva pumps that you see in the middle. Each reactor has one pump, and so we can continuously have a continuous inflow of the synthetic saliva that allows us to buffer the pH in the reactors. Each reactor is also equipped with feedbacks that are attached on electronic stirrers. You can see them here on the side. We keep the feedbacks in the reactors for 48 hours and change one of them every 24 hours. This attachment on the electric stirrers basically mimics the rumen digestion and the movement in the rumen to further simulate more realistic conditions. In each reactor, we also have integrated a pH probe that allows us to continuously monitor real-time observations of the pH and also automatically records the pH values each minute. Additionally, each reactor is attached to a separate gas bag so that we can collect the produced gas per reactor and time point. We estimate or quantify actually the volume of the produced gas every day, and we can also investigate the different gas compositions, for example, carbon dioxide, oxygen, and methane. So this is a small summary. As I already mentioned, the RUSITEC is a semi-continuous system. We can operate the system for 15 days. It is equipped with the 12 reactors with a filling volume of 990 milliliters per reactor. We have the continuous inflow of synthetic saliva. We have the feedbacks that we attach to this electronic stirrers. The feedbacks are basically nylon bags with a specific pore size so that the microbes are able to colonize the feed and basically then produce the short chain fatty acids. The aggregation, I already said, is done by this rotating axis of the electronic stirrers. We can then daily sample the rumen fluid from each reactor. We can also change the feed. Basically, we are feeding the reactors like in real time. And we can do routine analyses such as the continuous observation of the pH, the gas volume and composition per day, the dry matter disappearance of the feedbacks in the RUSITEC per day. And we can also investigate short chain fatty acids, total bacterial count, microbial composition, and so on. So this system allows us to really investigate rumen fermentation processes. And now I would like to give you a short introduction how we actually can simulate SARA, so subacute ruminal acidosis, with our RUSITEC. We have established a model that allows us basically this simulation of the conditions. So as a first step, I just give you a demonstration of a graph that you see for trial day 6 until trial day 13. And you can see the pH, the mean pH of several trials that we have combined with 6 replicates, RUSITEC reactors basically, all together. And the fat line that you see in the middle is basically the mean of all the trials. And the slimmer lines on the upper and lower ends are the confidence intervals. So this basically follows a normal physiological condition where we feed the animals a high fiber diet and normal buffer concentration. When we want to induce a SARA challenge, we can change the buffer concentration and the diet from high fiber to a high starch diet. And we do this basically from day 6 on, and we can observe during the next 3 to 4 days a continuous drop in these SARA reactors. So this is again the fat line in red, which are the mean pH values of several studies that we have conducted. As you can see, during the first 2 to 3 days, there is a transition period where the pH drops. And then from day 9 approximately, we have a stable condition, which is significantly lower than the normal physiological conditions, if you compare it to the green line, for example. So I just want to give you a quick insight in how actually the pH value looks like within 24 hours within this measurement period. And basically it looks like that. So we have again the pH curves in this measurement time that is indicated by the box. And you can really see now the pH values that are measured every minute for each of the reactors. So the green reactors are again the physiological normal conditions, and the red reactors are indicated as our SARA challenged reactors. You can see here the peaks indicate generally the opening of a reactor and the placement of a new feedback. After the placement of the feedback, the microbials colonize the feed and short-chain fatty acids are produced. This causes the slight drop in the pH that you can see in between the 2 peaks. And after the continuous inflow of the buffer solution, the synthetic saliva, you can see an increase in the pH before we open again the reactor here on the next day and feed again. So we can really see that we have successfully established the SARA model, where we have the continuous difference between SARA challenged reactors from normal physiological reactors. So what can we do with this now? So this allows us actually, or gives us the opportunity to test various feed additives as a kind of acidosis prevention strategy. And we have from our product portfolio several customized orientated solutions. And just one more example that I give you how we can actually test one of the products. So this is one example from a trial where we tested a product that is applied already at the beginning from day 1 to all reactors. On day 5, we change half of the reactors to the SARA conditions. So we change the diet and also the buffer concentration, and the other half remains the same as before. So with just high fiber diet and normal buffer concentration. And we can see that from this day 6 to day 8, basically we have this transition period where the buffer, the pH, is more or less before it is established. And then from day 8 until day 12, we have the significant difference of the SARA challenged reactors and the normal physiological reactors. And now here we can observe that even though not significant, the reactors that have the SARA challenge and the product, here indicated as green, have a significant, well, a numerical higher pH value than the reactors without the product. So we can use these indications to further analyze the effects of the product, for example, in further in vivo or in vitro trials. So I thank you very much for your attention. As I mentioned, or as Melanie mentioned before, the questions can be addressed in the Q&A section, and we will answer them later on or in the per email. So I hand over again to Melanie, who will inform you about the recruiting procedure. Thank you.
Thank you very much, Christina. So I think everybody wants to know now how to become part of the ERBER Group and BIOMIN. So I want to show you shortly, if you're interested, our career pages. You can check out our currently open positions on our ERBER Group job platform, and this is accessible from all our brand websites like BIOMIN, Rumen Labs, and the ERBER Group as such. We are offering different internships, bachelor, master, and PhD theses. These will be published on our homepage as soon as they are open. Also, entry-level positions when you finished your bachelor degree and you do not want to continue with a master or with a master besides working. And for master degree, like research associates, sometimes product managers, and with a PhD, of course, as a scientist or regulatory affairs specialists. So you can also select on the career platform or the job platform if you want to find a job for a young professional, or if you have already experience for experienced professionals. And of course, as soon as internships are available, you can also select them. If you do not find any suitable position, we are very happy to see your unsolicited application. Sometimes positions are popping up very quickly, so an unsolicited application is always worth the effort. So how does the application process work in our company? After you apply online, we will review your application, and your application will be forwarded to the responsible hiring manager. We will continue with the first and the second interview. After that, sometimes via video conference to cover the distance, or also in times of coronavirus, of course, we continue with video conferences, but of course in the second round interview you will get the chance to see your future workplace, to give a presentation, or to have a trial half day depending on the position you applied for. So now I want to thank you very much for your attention, and we are very happy to answer your questions. If you don't have any yet, please feel free to drop us an email to jobs@erbergroup.net. The email address is in the presentation.